Kelvin, Pat, what's going on?
Hey, what's up, man?
Hey, what's up, man?
Going on.
Hey, man, all good, man, all good. So we're about to start this long. I don't know if you ever watched Pokemon. We're about to start this long journey of IP routing for the next. How long, Claude? Probably forever.
Forever.
probably forever. But I think it was dope that after this long 3-week break that I took and the group took, I think it's good that we jump back in, but we baby steps jumping in. And I'm sure you guys saw my recent post. And I love, of course, you guys know I use network lessons for most of my proof of concept, and I love what Renee Molnaire said in his section about IP routing. And I think when I've spoken to a couple of folks, and I'm sure you guys can probably attest to this, is IP routing is different than IP route learning. Sometimes whenever we talk with folks, we tend to intertwine the two because we're either regurgitating or just regurgitating what they said or regurgitating maybe what the book said. So I had to compartmentalize, like, all right, what's this? So he said it perfectly. So before we jump in, I'm gonna read off what he actually says. I always put in my post ever since learning about it. The actual forwarding of IP packets by routers is called IP routing. This has nothing to do with the learning of network routes through static or dynamic routing protocols like OSPF, Claude's favorite, BGP, yada, 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 but has everything to do with the steps that the routers have to take when they forward an IP packet from one interface to another. And again, all this mainly is, it's not going to be a Q&A with you guys. It's more so just a review before we jump into the further sessions talking about these, any advanced stuff, But again, we're going to take our baby steps before jumping into these dynamic protocols. So let's go ahead and jump in. So let me go ahead and break down the topology. So we got two PCs, right? One connected to R1, one connected to R2. They're on different broadcast domains, okay? And so I want PC1 to go ahead and be able to ping PC2, and we're gonna go ahead and we're gonna follow the process on how to do that. My main goal is, and again, you guys can take your notes, tell me to slow down, is that I want you guys to verbally, right? We're gonna look at the technical side of it, but I want you guys to verbally be able to explain the path of a packet so that when you guys go to interviews, when you guys are troubleshooting, you're able to understand, okay, all right, so we got a couple of clients who can't X, Y, and Z. Let me slow it down and think about the process of what happens with the packet of a packet. So first things first, we got PC1. PC1 and PC2, it's off now, right? And I set up R1 and R2. They have the DHCP running, so PC1 and PC2 will be able to get an IP address. So I'm fine there, okay? And so the DHCP process is gonna happen. And so as far as the, with the DHCP process and getting it on the network, what's gonna happen is PC1 is, of course, is gonna do that DHCP discover, trying to say, hey, who's a DHCP server? R1 is gonna go ahead and say, hey, I'm the DHCP server, hand it an IP address, okay? So it's gonna give it, it's gonna get, do the door process, give it its IP address, give it an IP address, and PC1 is going to, lock in some information about it. And that's what we're gonna break down, okay? So let's go ahead and turn these bad boys on. Perfect. Okay. Let's go ahead and double check and see if it has an IP address just yet. Okay, cool. So PC1 doesn't have an IP address. Just like I said, I'm gonna make sure that it gets an IP address. I'm gonna do run a command called DHCP on this VPC so that I can go ahead and get it. And if I'm not mistaken, it should go ahead and get an IP address. Boom, as it should. Perfect. Okay, so it has an IP address, okay? And let's do the same thing for PC2. Okay. So got that. Perfect. So we got an IP address. Okay. Pull that up. Okay. So like I said, the goal of this, I want PC1 to go ahead and reach out to PC2, right? I wanted to ping it, successfully get there, what have you. Okay. We're going to assume that one, routes are already configured, what have you. We just want to see the process of what's happening. So let's make sure we take note of the MAC address of PC1. Let me go ahead and mark that down in 1 second. We're definitely going to talk through this. Hold on. Let me do a notepad.
Oh, you're using a Notepad++. Anyone use a customized color code for their Cisco configs?
You just brought up a good point. Let me go ahead and just use Visual Studio. Keep it simple.
Only on CRT. If I was using like CRT or something, I did that once.
Okay. All right, perfect. Go ahead and bring this over. Let's go ahead.
That's pretty.
You said what happened?
That's pretty.
Yeah, yo, I'm using the I don't know if you guys heard of it. It's what is it? Legend of Zelda theme on Visual Studio.
Okay.
Yeah, so yeah, I'm using that. Yeah. So we have, like I said, we're doing the path of packet, and we're going to trace the packet going from PC1 all the way to PC2, and see what happens at each interface. You know, each interface that's doing a layer 3 function. Okay. So we're going to notate PC1. Can I notate? Well, let me see. Yeah, PC1. Okay. Mac 050 79 66 68 01. IP 92.168.1.2. Cool. That's 24. So we got that. Now let's go ahead and mark PC2. And again, I'm doing this so we can go ahead and track it, so y'all can see it real time, and we can go ahead and do some comparisons within Wireshark. Pop that down. Cool. First. So that MAC 0, 0, 0, 79, 6, 8, 6. All right. The IP is 192.68.2.2/24. Perfect. All right. So we got this. So now that we got that, now the first thing, right? The first thing, and I'm sure you guys saw my post, the first thing each host is going to do, right? Any host, whether it be Windows, Linux, or what have you, whenever a packet, a packet or a host wants to send a packet to a destination, it's first gonna say, hey, all right, so I know what the user wants to do. It's gonna ask itself, is the destination local or remote? And how it answers that is it's gonna go ahead and take a look at the destination IP address and see and compare it to its own. Hey, okay, is it part of my same subnet? So for this, right, we have a 192.168.1.2/24. So it's in a 192.168.1.0/24 network. Our destination is 192.168.2.0. So it's not local, right? So what the PC does, no matter what operating system, it's going to say, perfect, I need to go ahead and send it to my default gateway, okay? And so what's going to happen is it's going to go ahead, and it already has pre-configured its default gateway. It's going to go ahead and do a ARP, right? And try to see, all right, perfect. Do I have this default gateway's address in my ARC table, you know, so I can go ahead and encapsulate it whenever I'm going from layer 3 to layer 2 and then down to layer 1 to go ahead and send it on the wire. Okay. So let's go ahead and take a look at that ARC cache and see if we have R1's IP address to MAC address mapping on there. That command should be cool. So ARC table is empty, okay? And so what I'm doing as well is I'm doing packet captures on R1. All right, so let's go ahead and see what happens when we go ahead, we do a ping. We'll go ahead and ping the destination and we'll be able to talk through the rest of this. Cool. Perfect. Perfect. We can stop that. All of these. Perfect. All right, so this is, right, capture 3.0, this is this interface, okay? So like I was saying, right, what it has to do, because again, it has to go ahead and even though it has that destination IP address, let me pull up Visual Studio Code. It has that destination IP address of that different subnet, but it needs to know the MAC address, right, of the default gateway to go ahead and know where to send it at layer 2. And guys, remember what we said in previous lessons whenever we were talking about layer 2 and doing the path of the packet. Whenever you're talking about an IP packet, the source IP address and the destination IP address, it will never ever change. There's some cases, of course, of packet rewriting, but typically the source and destination won't ever change. Okay, but at layer 2, per hop, meaning per layer 3 boundary, it's always going to change. Okay, so that next layer 3 boundary is our default gateway. So we need that MAC address before we can go ahead and shoot it up. So since the PC is so smart, right? Windows PC or whatever PC we're using, it's so smart it's saying, all right, cool. Let me go ahead and set an ARC for my default gateway, which is what it did. It said, hey, who is 192.168.1.254? Okay, so it went ahead and shot that out there, has a broadcast. Then it went ahead and gave us a reply. All right. It went ahead and sent another broadcast back from that host who has an IP address saying, hey, this is my MAC address right here. So now what's going to happen is, probably can take a look too. You look at that PC, it's going to, hold on. It's going to go ahead and probably have the default gateway in its ARC table. So now that it has it in the ARC table, it now knows, okay, cool. We can go ahead and we know who to send it to as far as the next hop. We know how to encapsulate it at layer 2, okay? So once it does that, and we're gonna go ahead and confirm interfaces or what have you, go ahead and take a look at it. And this will help y'all folks too whenever you're troubleshooting or looking at stuff and get some understanding. Let's do a show interface, that interface, gig 0.0, 0/0. Too much fluff. Let's go ahead. Food. All right. Perfect. So what I'm expecting to see, right? I'm expecting to see this right here. Okay. But if I go to another capture, right? Because now that path of the packet, the router is going to get it, look in its routing table, and go ahead and work on routing that packet. We're going to get back to that. But when it leaves here, that MAC address shouldn't be the same. Let's go ahead and take a look at it. Perfect. So looks like that MAC address isn't the same as that first interface, gigabit 0/1 on R1. So it changes again every layer 3 boundary as far as the router. Because again, the router's job is just to route that traffic, right? and it's going to go ahead and make sure it de-encapsulates at layer 2 before it can look at layer 3. That's why that layer 2 header and trailer is going to be stripped off every time it crosses that router. Okay. So we see it. It's all good. We have our MAC address. Now let's go ahead and take a look. I do want to explain that process. Now that, let me blow this thing up. Right. So we know our pings got there successfully. Talk about what the router is actually doing. IP route. And Claude, feel free to jump in whenever I speak about this. So whenever that router, right, and let me pull up this again, a little bit better, right? So if we take a stop here, right, let me get my little handy dandy annotation thingy-majig on Zoom, make it green, right? So when that packet gets there, right, we know routers, right? They don't forward, broadcast messages, right? But they will process it, okay? And so again, it's going to go ahead and receive it. And what that router's doing is it's going to go ahead and get that frame from PC1 or the packet, whatever you want to call it. It's going to say, all right, perfect. I'm only going to respond to this or do an action to this if, one, the destination MAC address is the address of the interface of the router. B, the destination MAC address is a broadcast address of the subnet that the router interface is connected to. Or C, the destination MAC address is a multicast address that the router listens to. If it isn't any of those things, that packet's being dropped by the router. Straight up, right? And another reason, right, that the packet will be dropped, and again, Claude, go ahead and keep me honest here, is if, right, whenever it receives that that packet, right, and it checks that layer 2, it checks the FCS, right, the frame check sequence. If that isn't correct, the router's going to drop that as well. Okay, right? But one thing I did learn within that lesson that I'm going over IP routing is layer 2 and layer 3 doesn't have any error recovery mechanism. So if that, again, FCS, and of course, if we go to layer 3, we'll touch on that in a second. If the header checksum at layer 3 is incorrect, again, the router's dropping that packet. Okay, so router gets that packet, and what it's doing, right? It's once it checks the FCS at layer 2, the header checksum at layer 3, it's going to go ahead and look at the IP packet and say, all right, perfect. Let me look at the source. Let me look at the destination, right? And if we pull up, right, that VS code, where we mark down everything, we see our source, 192.168.1.2, and our destination, 192.168.2.0, okay? And so we see we have a route, right, for that network, 192.168.2.0, okay? And so we reach there by 10.10.0.2. So we do have a route. But one great thing I did learn, and which was actually awesome, and I don't think I heard about it, recently or within my studies, is that once it gets its primary way on how to get to a remote network, it also needs to do another lookup for that next hop, okay, to see if it has that within the network. So let me do this. So we have this route, right? 192.168.2.0. So we know how to get to PC2, right? But what the router is going to do as well, it's going to do something called a recursive routing lookup to see, all right, what's the route to get to my next hop? And so that's a connected route here. So we already know how to get to 10.10.0.2. It's on the same network. So I'm gonna go ahead and push that out of this interface, gigabit 0/1. Okay. So once the router knows all of that, it's gonna go ahead and start packaging it up. It's gonna do the same thing that PC1 did. Check its ART table, see if it has for 10.10.0.2, if it has a IP to MAC address mapping to it. If it does, perfect. I can go ahead and package up, at layer 2, the MAC address where I need to send it to get to the IP destination of 192.168.2.2. Okay? And if it isn't, it's going to do the same thing. It's going to do ARP. If it isn't in the IP to MAC mapping or ARP table, it's going to go ahead and do the same thing that PC1 did. Do an ARP request, get an ARP reply, and then do the same thing. Okay? So once it does that, we're going to go ahead. Which one, again, I was testing this week. Let me go ahead and erase all this. Bring that out of there. There we go. But I was testing, again, just to test my knowledge, just to make sure, again, I went ahead and did a packet capture on my earlier labs on switch 1, just to see if the switch is manipulating, manipulating anything at layer 2, what have you. But no, it's just, again, doing its 3 major functions, and just forwarding that traffic based on that, based on the source and destination MAC address. So no manipulation of layer 2 is happening there, only on those layer 3 interfaces or layer 3 boundaries. So pop that. So let's go ahead and there we go. Go back to R1. Let's go ahead and take a look at that interface. Give it 1/0. So what I expect to take a look at is to see. Go ahead and pull up VS Code. I expect to see within that packet capture that interface, right? So I'm going to go ahead and write that down. Give me 1 second. 2, 1. Back. Three, 0, 1. All right, let's get that IP m.10.0.1. Okay. Shoot, just for organization, let me go ahead and add to. Go ahead and put inside interfaces information there too. Keep it consistent. Thousand and 1, 3, and 0.0.0.0. Perfect. That IP 92.168.1.254. That's a /30. There we go. Perfect. All right. So now we got that information, right? We know the interface that it's leaving out of. For our routing table, let's go ahead and take a look at R2. Once we go to R2, we're going to go ahead and pull that information. Oops, don't need to go into config. All right. Finish gig 2. This. There we go. All right, let's go ahead and get that down. 2. Now, this is the interface that is on the same broadcast domain as R1. And then the interface that's connected to PC2 is gigabit 0/0. Get all this information. 1, 5.0.2, IP address 10.10.0.2/30. Let's get that inside interface. So you go ahead and mark it down whenever we go ahead and look at those packet captures. Boom. Right. That 1, 0 per 2.168.2.254/24. Perfect. All right. Let me pull up the routing table too. We'll come back to that. Cool. We'll come back to that. So now let's go ahead and take a step back and let's go ahead and let's take a look at these packet captures. So this packet capture, this is on gigabit. This is on gigabit 0/1 on router 1. Okay, so what we should see, right? Whenever if we're talking about PC1 sending up, ping PC2, right, and R1 doing its process, de-encapsulating it and re-encapsulating it, we should see at layer 2. We should see the MAC address of the interface facing towards R2, right? Which is right here, 5000.001, 003, 001, right? And we see that, right? And our destination should be, right? It should be R2's gigabit 0/2. And we see that. We see that there. It's going the right way, right? That, again, layer 3, that's not changing. That's staying the same. Remember that. But as we also could see as well, we also see that 10.10.0.2 wasn't in R1's ARP table. So it had to go ahead and send a ARP request and go ahead and get that reply so it knows how to go ahead and set that destination layer 2 address so it can properly encapsulate it to send it to that next hop. Okay? So we got that, right? And again, it's doing the same thing. Same thing that the PC1 did. De-encapsulating it, re-encapsulating it, right? R2 is doing that. And what R2 is doing after that, it's doing the same lookup, the first lookup of to see, hey, is this connected? Is this subnet, is this destination IP address, is this located on my router? Do I know how to get there from my router? It's going to go ahead and say yes, because we have an interface that's connected to 192.168.2.0. So we don't actually need a router. So we're going to go ahead and shoot that down the interface gigabit 0/0. Let me go ahead and get my little marker, which is right here. So it actually doesn't have to do a recursive lookup. Now, right, whenever those ping replies are getting sent back, R2 is going to go ahead and do that recursive routing lookup again, because 192.168.1.0 is on a different network. So it's going to go ahead and do that, right? And so once it does all of that, let me go ahead and erase that. Boom. It's going to shoot it down 0/0. Encapsulate it. Pop that out. It's going to go ahead and encapsulate it with that layer 2 address of PC2. It should be here. Yep. And if we go ahead and look at Visual Studio Code that has our information, we should see the destination MAC address and the IP address of where that packet is going. So let's go ahead. Boom, pull that up. Perfect. So Router 2 did exactly what it had to do. It had to go ahead and send it, encapsulate it with the layer 2 MAC address of PC2, and it also has the IP address of PC2 as well. Again, that would never change from any layer 3 device that would have you. Of course, we have our certain instances like DHCP relay would have you, but in this case, typically it doesn't. So just to go ahead and summarize, right? The host has to make a simple decision, of course, whenever it's trying to send out that packet. Is the destination on the local subnet? What it's going to do is going to go ahead and check that ARP table for the destination IP address. If it's empty, it's going to send an ARP request, okay? If the destination is on a remote subnet, the PC is going to go ahead and check its ARP table for the default gateway's IP address, and of course check for the IP to MAC, mapping. If it's not there, then it's going to go ahead and send an ARP request, right? So then whenever that packet goes ahead and gets to the router is going to do a couple of tasks, right? When it receives the Ethernet frame, it's going to go ahead and check to see if the FCS layer 2, the frame check sequence, is correct. If not, it's going to go ahead and drop it, right? If that's clear, it's going to go ahead and look at the other parts of the layer 2 address, right? The header and trail. It's going to say, hey, I'm going to go ahead and see if, this layer 2 frame falls within the following, right? If it's destined to our MAC address of wherever we're receiving it from, if it's destined to a broadcast address of the subnet that this interface is in, or if it's destined to a multicast address that this interface listens to. So that's possible as well, but we'll get to multicast in a later session, right? Then once it does that and it processes it and it does fall into one of those categories, then the router is going to go ahead and de-encapsulate the IP packet from the frame. We're going to go ahead and drop layer 2 to header and trailer. Boom, discard that Ethernet frame, and we're going to go ahead and process the IP packet. Then the router is going to go ahead and look for a match in its routing table for the destination IP address. It's going to figure out where it needs to go, what's the outgoing interface, and see what the next, hop address, IP hop address is. Okay. Once it does that, it's going to go ahead and knows where to send it. If it needs to do a recursive routing lookup, it'll do so. But when it is ready to go ahead and get sent out, it's going to go ahead and shoot it out. And I know Claude will kill me if I forget this. It's going to go ahead and decrease the TTL of that IP header by 1. And it's going to go ahead and make sure it recalculates the header checksum. Okay. Once it does that, the router, the outgoing interface is going to go ahead and put all that within the IP header, encapsulate it within a new Ethernet frame for that interface that it's leaving out of. Does another ARP table lookup and check to make sure it has the IP to MAC address mapping for that next hop. If it does, it's going to go ahead and transmit that frame. It's going to keep happening till it gets to that destination between routers. And with that being said, that's the path of the packet from a layer 3 standpoint.
Oh, that's dope. Can I ask a question?
Oh yeah.
Okay, cool. So in this example, right, we have the two routers. So router 1 and router 2. Mm-hmm. If a PC1 from router 1 goes to router 2. So my what I want to grasp is if router 1 knows, okay, it's obviously not going to like push anything back to PC's 1 interface. Is it automatically going to shoot to the the gigabit Ethernet 0/1 if it has no clue about that? Or how does it, that's what I'm trying to understand. How does it know to send it to gigabit Ethernet 0/2 and not just drop it? And I know you probably went over this because I was kind of driving, but I just want to get like clarity on that when it knows to say, okay, I don't know this, but I might know somebody who does know this.
No, it's all good. It's all good. And I'm glad you checked me on that because we were supposed to touch on that. So, right, and Patrick, again, good point you brought up. So the router is only going to route packets based on routes it knows that it's programmed with, either statically or dynamically. Right. If it doesn't have a way to reach a destination, that packet is dropped. It doesn't know where to send it.
Okay.
It just doesn't know where to send it. So in this case, right, I went ahead and before this lab, I statically set the routes, right, for different subnets or what have you, set the remote subnet, then set the next hop, right? I make sure I set that on the routers, right? But again, just to answer your question, if those routes, if a route for a certain destination doesn't exist on a router, the router logically doesn't understand where to send it. It's going to go ahead and drop it. It can't perform its job. And it only has our expectation of the router, right? Router, switch, or what have you. It's programmed to do it in milliseconds. If it can't do it, it's going to go ahead and say, hey, I can't waste any process. I'm going to go ahead and drop it. Okay. So then it'll be up to us, the IP administrators, the IT administrators. I'm sorry, the network engineers or what have you. We got to go ahead and go in and see, okay, why can't the sales department reach our file servers that are at our St. Louis site? Let's go ahead and see what's going on, right? And so that's when we start doing what we just did, path of packet, checking at each device, making sure everything's running smoothly. And if we're missing that, then we go ahead and program what we need to program. And we engineer how we want packets to roll from a source to a destination. That's where that engineering piece of being a network engineer supposedly comes in.
Yeah.
Okay.
So on the topology, you see he has the two networks, well, actually there are three networks, 192.168.1, the 10.10, and the 192.168.2.
Right.
So let's just say if for some reason PC1 sends a packet out to 192.168.70. Dave, that routing table that you brought up earlier, bring that CLI back up. Of router number 1.
Give me 1 second. Let me go ahead
Okay.
and do that. You said router 1?
Yeah, you had the routing table up.
Yeah, I got you. There you go.
Okay, so like Dave was saying earlier, if it doesn't know, it's going to get confused. If it doesn't know where that 192.168.70 is, right?
Mm.
So the routing table is going to put its best routes to get to a given network. Like you said earlier, everything else is going to get lost.
Uh-huh.
Okay. Now, even before the router determines that to get to 192.168.2, it actually has to look at its forwarding table. So the routing table gets its information from the forwarding table.
Okay.
And if you would, Dave, if you would pull up show IPsec. This is the forwarding table.
Oh, this is
drill
new.
it down. Hold on. Let me drill it down. Hold on.
Okay. Okay.
Yeah, that might be a lot for folks. Give me 1 second.
Okay.
I got a quick question, Claude.
Okay. So here you go.
Okay.
So the forwarding table is where the routing table determines what I'm going to put in here as the best path. So what happens is the forwarding table says, all right, to get to that 168.2 network, okay, we're going to go to the 1010, which is the switch, and we're going to push it out gig 01.
Okay.
So the routing table populates its table based off of that information.
Okay. This is new.
So Dave, if you would do a show IP route pipe, include 192.168.2.
Gotcha.
Or just do a show IP route 192.168. You could do that. It should.
Gotcha.
Yeah, it should be smart enough to do that. There you go. So as you see here, it's telling the routing table says, all right, to get to that 168.2, we're going to go, our next hop is going to be that 1010.02, which is what the forwarding table told us earlier.
Gotcha. Okay.
So if you so if you look at the grand scheme of the routing table, just give me a show IP route. And you'll see at the very bottom down there, the same thing. It's statically configured.
Gotcha. And that one is because it's static as far as
right.
Okay, gotcha. Okay, so essentially it has to have a routing protocol, obviously, for it to learn it, or it needs to be statically assigned.
Statically assigned, right.
Okay, so, and that's how it knows if, because what I was kind of like trying to understand is what if router 2 doesn't have like PC2's ARP, like PC2's MAC address. Like, you get what I'm saying? Like, is it still going to, like, how does that work? If, say, I just connected PC2 and knows IP, well, no, it wouldn't have an IP address in that case because router 2 would have to assign it, or it would need to have the default.
So like Dave talked about, he gave you 2 scenarios.
Yeah.
Trying to figure out something, if something's on a local network or if it's on a remote subnet. Okay. That's where ARP's going to come into play at.
Okay.
And so Pat, just to I think I got a good example in real world terms, right? Let's say you sent me money to get you a PS5, right? It's an expensive thing. I want to make sure it gets there. Okay.
Yeah.
Shit, I want to play Call of Duty myself. I want to shoot some zombies. Okay. But right. For me to go ahead and send it to you, I need your address. I need to make sure I know where it's going. Okay. Right. Let's right. If I don't have your address, what am I going to be? I'm going to be confused, right? Because I don't know where to send it.
Mm-hmm.
So I'm going to just sit on that PS5 until I know where to send it. Hell, I might eBay that thing. I might go ahead and put it up for auction if you don't send me your address quickly. But does that make sense? If I don't know, if I'm the router, right? If I don't know where to send it, you know, right? I don't know what to do with it. I literally don't know what to do with it. Okay. So I'm waiting for Patrick, right, to tell me, hey Dave, this is where you send it. And this is you being the engineer, right? And I'm the router. Hey Dave, send it to here. Perfect. I know where to send it. Boom. Go to the post office. I mean, I might keep it for a couple of days, but you know, eventually I'll go ahead and send it to you. But yes, that's essentially how it works. Does that make sense?
Yeah, yes. As long as you don't de-encapsulate my PS5 before it get to me.
So look, hell, you know, y'all know I love a lab. So Pat, you brought up a good point. Let's see that in real time. Let's go ahead and remove this static route and let's see what happens within I'll take a new packet capture. Let's see what happens to R1 whenever it doesn't know how to get to PC2. Okay.
Sounds good.
Go ahead, pop that. No IP route. 68.2.0. I'll need to put the whole thing. Damn it, I do. Oh, there we go. 1, 2, 3 IP route. First, okay, so it's not there. So let's verify. Show IP route.
And it's removed.
Perfect.
Okay.
Perfect. So that route is not there. Okay. Let's go ahead. Let's go ahead and fill all these packet captures. Do a new capture. We're going to do one on the and remember, ingress and egress. We're talking about direction. The direction of traffic is going from PC1 to PC2. Ingress, right, would be coming into gigabit 0/0. Egress would be 0/1. So I'm going to, does that make sense, right? Perfect. My man still remember those layer 2 sessions. So I'm going to capture it ingress and egress, okay? And ingress, what we expect, right, since it's directly connected to the PC, is that those packets come into that interface. Those pings come in.
Yeah.
But what I also expect, right, all of us being engineers, we expect egress, since the router doesn't know what to do with it, we expect that it's not going to send anything out. It's not, nothing is going to leave, and we're not going to see anything in that packet capture whenever it's egressing the switch, okay? And we're going to start using these terms because, again, all of you guys, it's coming up close. A lot of you guys are going to become engineers. You're going to have to know these terms, okay? Claude, real quick. I know you're good with the debug. You my man with the debugs. Is there any debugs where we can actually see what the switch is doing? Whenever it's trying to do those IP routing lookups and forwarding and what have you.
Let me pull up one of mine real quick. You can probably do a debug packet. Let me see here.
Take your time. Let me go ahead and hell, we can question mark this bad boy. Calvin, you know what that is. We can go ahead and question mark that thing until we figure it out. Go ahead, debug. Let me see if I have anything for IP routing.
Wow, it's a lot of debugs. Sheesh.
It is. Okay, so IP address manager information.
Yeah,
no,
show IP
information.
show IP debug routing.
You said show
debug
IP.
Yeah, debug IP routing. That'll probably be what you're looking for.
Okay. Debug IP routing. All right, perfect. So we got debug IP routing on. Let's go ahead and bring up. Perfect. All right. Let's see what's going on. Let's make it a little bit better. Run it again. Let's go ahead and check the other packet capture. I can do continuous. Let me go ahead and check that. There we go. We gotta keep on having it rolling. So, right? So in Claude, I don't think the debugs popped unless it probably has something to do with the software. Which, you know what? Now that I think about it, Claude, would the debugs pop if it doesn't have a route to the network?
If it's nothing to show, if there's no decisions being made.
No biggie, no biggie. So again, we can go ahead and look at this as we know it, right? So let's go ahead and decipher this real quick. We don't need packet capture running down our damn network. So, right, we're receiving that packet, right? Let me go ahead and make this a little bit. I don't need all those packets, right? First, so we see the packet, right? The source, 192.168.1.2, right? That's PC1, okay?
Yeah.
So we have that. We have that, right? It's being sent. It's being sent out, right? But we don't get that response. And it tells us no response seen, right? And it's sending it, right? Let's go ahead and pull up visual code, right? It's sending it to its default gateway. It's sending it there. We see that layer 2.
Yeah.
We see it. But now our router is giving a response. Damn it. Our router is giving us a response, right? Telling us destination unreachable, right? It sends us something back, right? And that packet is never leaving because, right? Of course, it tells us, the packet capture tells us, hey, destination unreachable. But, right, logically, right, with our packet captures, if you guys are all being engineers and digging deep, you guys can see it's never egressing out that port, is it?
Nope.
We're not seeing no pings traverse. So to answer your question and to test Patrick's question, theory, what have you, if it doesn't have a route, it's going to drop it. It doesn't know where to send it. It's just going to sit on it.
Yeah.
But in this case, we went ahead and confirmed, our analysis confirmed, it's not going to sit on it. It's going to send back a message to the router, to the PC, and be nice and say, hey, I know you want to go ahead and send a packet out, but we don't know where to send it. So you're gonna have to, you know, get your network engineer to figure something out. You know, to go ahead and engineer something so that it can get to its destination.
So it's similar to like when you send out a package and say that you put an address on it that doesn't exist at all. So it traverses, it tries to get to where it is, but in this case, it's just staying at the post office. But the post office receives it and say, hey, wait a minute. I don't know this address. This is not populating in anywhere else. So you know what? We need to go ahead and return this back to sender. It doesn't necessarily return back to sender, but it returns back the message saying, hey, look, we don't know where this is. So, we want to help, but we can't do anything because we don't know where it needs to go.
Exactly. Like the post office doesn't have an address to Bowser's Kingdom. So we about to sit on that PS5. Listen, you're never going to get it. Right, and the post office is gonna let me know. You know what? Pat ain't even want this PS5, so they go ahead and keep it. We can't send it. And just don't call Patrick. No, I'm joking. But yes, that's essentially what's happening here, right? The post office is letting us know there's no way for us to reach your destination. We're just letting you know, right?
Oh.
And so this is what happens. This is the process that's happening whenever that router or a router or a multi-layer switch performing any layer 3 functions can't send out, its packet and do its function that it's supposed to do, which is layer 3.
Got it.
Does that make sense?
Yeah, that makes total sense. So yeah, it's getting there. So and I've looked at this plenty of times, but again, when you're looking at it, where it's like you're looking at like Wireshark, and you're literally looking at by the bit, it kind of gets overwhelming sometimes. So that's why it gets
overwhelming.
Yeah, you got to slow it down. Theoretically think about it, and like you say, keep it simple, stupid. Not saying it stupid.
That's it.
Me personally, like
nah, I got you. You good. But y'all, Patrick brought up a good point. And I don't mind being transparent, dude. I got overwhelmed. When I was working on the NOC, my first troubleshooting call, and the engineers just telling me, Dave, take a packet capture. Dude, I don't know what I'm looking at. There's a whole bunch of things going on the screen. I still haven't beat Super Mario Brothers. So, dude, if you think I'm confused by Super Mario Brothers, shit, get a load of this Wireshark capture. I'm confused. But then when I went ahead and took the time, I'm practicing within my lab, all the labbing that you guys are doing. And again, I know a lot of you guys are doing on, Packet Tracer, but I'm gonna push you guys, right? Because now we're going into the next phase of this group's training. Is you guys are engineers. I need you guys to be able to pop a Wireshark capture. A lot of you guys have real devices. Go ahead and do you guys know how to do that. If you don't, we'll go ahead and have a session. But I want you guys to get used to looking at a Wireshark capture and understanding what you're looking for. Okay? Understanding what you're looking for. We'll go over that. We'll go over all that, all that stuff in the future. Definitely. But you just have to know what you're looking for. We'll go over that. But again, one quick little thing. If we know, right? If we know we're just looking for pings. I just want to see pings. I don't need to see anything else. If I'm looking for certain IP address, let's say our source.
I think it's
1.2, right? It's 1.2? Yeah, it's 1.2. Right? Right? And that's showing me all matches within this Wireshark capture for this address. Now, what if I just want to look for this address, but only has the source? Okay? Make sense, guys?
Yes, sir.
Cool. Again, this isn't going to be like a quiz. I didn't want this to be like a quiz section on you guys. I just wanted to go over IP routing because since our new cadence is going to be every 3 weeks, whenever we come back, hot seat, be ready. Be ready to get sweaty because it's game time. It's going to be a big topology.
nice.
Okay?
Cool, man. Cool. I'm looking forward to it.
All right, folks. Guys, anybody has any questions before we peel out? Again, this is just a short session. Didn't want to make it long. We were just touching on these fundamentals we're having.
All my questions were answered, so I appreciate it as always.
Okay.
Yeah, good.
Cool.
Good to have you back.
Yeah.
Hey, man, it's good to be back, brother. It's good to be back. Well, folks, man, good stuff. Again, excited to see you guys in 3 weeks. I'll drop some more documentation to help you guys out. But yeah, just be ready. We're gonna jump in. I know a lot of you guys. I know Angela, he's on here now. I know you guys want to dig into those dynamic routing protocols, and trust me, that's Claude's baby. So listen, we'll have enough fun with that. I just want you guys to understand the fundamentals before we jump into it. And again, those routing protocols look good, but if you guys get into a situation where you don't know how to both talk the talk and actually understand the theory, you guys are just infatuated with just the technology and not really adding value. Okay?
All right. Yeah.
All right, folks.
All right. Good night, everyone.
All right, man.
All right.
Now.
Later, folks.
Yes.
Thank you.
Everyone.